I will now hand you over to John Smith from voestalpine.
So yeah, as I said, thank you, Simon. Delighted to be sharing a virtual stage with you today for this presentation. And just very brief intro from my side. As you can see from the screen, I'm John Smith. I'm CEO of voestalpine Signaling UK. I've been working here now for about 6.5 years. And before that, I was with Network Rail in the UK, where I was responsible for their intelligent infrastructure program, also deploying condition monitoring systems throughout the UK infrastructure. So I now have about 15 years of experience, actually, time's flown, in this particular area of the railway. And here in the UK, we are part of what we call the Digital Track Solutions Competence Unit in voestalpine Railway Systems. And we're specialists in digitising infrastructure assets using asset condition monitoring systems. So very briefly, Railway Systems itself, we're a global company, 60 plus locations worldwide, 7,000 plus employees, and more than 160 years of experience in the field of railway infrastructure. Clearly the monitoring side of that is more recent, but nonetheless, in terms of turnouts and rail, for example, we have many years of experience. And our vision really is to become a comprehensive system solution provider for the whole track system. And today we're going to focus a little bit on the high-speed turnout system relating to HS2. And as you can see from the picture here, we have within our scope of supply all of the various elements and systems required to provide an integrated turnout system for a railway like HS2. And our strategy is entirely compatible with HS2's own desire to consider S&C as a system and to benefit from the integrated approach that we're able to present. So what I'm going to do now is just run briefly through our main areas of supply for the turnout system before I come on to a little bit more focus on the monitoring side, in which I'm far more experienced. But firstly, in the turnout itself, we have a number of key innovations that we bring to HS2. Kinematic gauge optimization to manage the gauge right through the turnout itself. Swing nose crossings, very common now, particularly for heavy haul railways and of course high speed rail, to enable the kind of diverging speeds that these railways require. In the case of HS2, up to 230 kilometers per hour diverging speed. And we use double clotoid geometry in the turnout, which graduates the turnout and enables high-speed divergence with minimized lateral acceleration and minimized jerk to improve passenger comfort over the turnout. We also provide the full fastening system with elastic elements to manage stiffness throughout the rail, particularly in the transition from the permanent way into the turnout, and the full point operating equipment, so external locking devices with drive systems and end position detection for all turnouts, both on main line and in depots, and with some of those main line turnouts having up to 9 separate setting levels on the turnout itself, plus a further 4 in the movable point frog. So very large turnouts. I think in terms of global railways, these will be the biggest turnouts ever delivered for a railway globally at this point. And then finally, we'll come on to a little bit more detail, a fully integrated and modular asset condition monitoring system to support the high-speed turnout system. And in fact, not shown on my slides, but it was brought to my attention, we're also supplying rail expansion devices. So for structures such as that which you see soaring over Simon's Head in his Zoom background. In order to help manage the expansion and contraction of big structures like that, we need to have rail expansion devices in the track, and they will also be supplied from railway systems, and again with a fully integrated condition monitoring system to provide real-time asset condition information back to the integrated control center in Birmingham to enable better asset management of those assets also. So just looking in a little bit more detail now at the monitoring system. So for many years, and many of you will be familiar, monitoring in switch machines has been used on railways to provide this kind of condition information that we're looking for. And they're very, very effective solutions, particularly at understanding condition of the point operating asset itself. So for example, motor condition or condition of the hydraulic system in the use of electro-hydraulic switch machines, and failure modes such as a reduction in fluid level or leaks in the system can be readily identified through the point machine. As you get further away from the point machine itself, further down the turnout, the point operating monitoring becomes somewhat less effective, particularly in very long turnouts, such as those used on high-speed railways. And so by the time you reach the crossing area, for example, you're some way away from the point machine, and therefore less able to glean information from point condition monitoring. So with what we call our intelligent turnout concept, we've, in a modular fashion, provided additional sensor systems to gather data from various elements of the turnout system. And these are modular to enable, as Simon explained for HS2, for example, a risk-based cost optimization of the monitoring solution, depending on the particular characteristic and the particular use case for a given turnout. So in the case of very high speed mainline turnouts, it may be appropriate to select all 5 modules of the intelligent turnout system. But in situations where the risk is deemed lower, for example, then only certain elements of the solution can be selected to enable us to match the monitoring system to the real world requirement of the infrastructure. So just briefly in summary, those 5 elements, as well as the intelligent switch machine, we also monitor at the switching point itself, and we look at position of the switch rails relative to the stop rails in real time. We can also have sensors fitted to the sleepers to identify any movement in the track. We monitor temperature throughout the turnout, both from the structural elements, but also the environmental condition, the environmental temperature, the ambient temperature. And we're able to identify overall track quality, or in the case of ballasted track, ballast condition, using sensors mounted to the sleeper, as I mentioned before. And then finally, we now deploy sensors also in the crossing area to look at this very, very critical part of the S&C system. I'm just going to have a look at an example of how we do that monitoring in the crossing area, just to illustrate the point. So you can see in the CGI here, a sensor bonded directly to the crossing structure. And this is what we call a structure-borne acoustic sensor. And it's rather like a tuning fork in my mind. So when the train runs into the crossing, the force generated by the wheel rail interface produces a response in the crossing structure, rather like the note played by a tuning fork when you tap it on a table and impart a force on it. And that tune played by the crossing is very much characteristic of the train passing through the crossing. And what happens is, of course, if there's a deterioration in any element of the system in this area, then the note played by the structure changes. And we can detect that with the structure-borne acoustic sensor and use that to identify in real time the condition of the asset. So for example, there's a very characteristic pattern where the wheel transitions from the running rail through the crossing. And if the crossing nose is wearing, then that characteristic signature changes, and we're able to identify that and therefore provide an ongoing instantaneous asset condition, but also a trend of the wear on the crossing nose, and that then allows for predictive maintenance to be scheduled based on the asset management plans that Simon was talking about from HS2. And similarly, the condition of the running surface also will change the data that we record through the system, and therefore we can indicate where we're seeing damage either to the running surface of the crossing or to the wing rails in the crossing area. And data from these sensors is all brought back to a central system, and this is really the brain of any condition monitoring system. So acquiring data is all very well, but if you're not able to translate that data into information that can actually be used by the maintainer, then you're not fulfilling the full value potential of a monitoring system. So we're able to bring that data back, perform analytic analysis on the data in order to provide both real-time status and trend information. But in the same environment, either within a single software environment or through interconnection with other systems, we can also use that to integrate maintenance activities, for example, through the scheduling of intervention work. We can visualize status, we can visualize the full system, in fact, through digitization, so effectively through a digital twin of the asset, and even connect that into an asset register. So, for example, if there is a predicted error in one of the systems, then we're able to look up the component number, the part number, check the logistics situation to see if there are any components in any of the depots locally for replacement, or order a component if required. And of course, that's all coupled also with reporting functionality. So all of these capabilities in asset management are really enabled by having an integrated software solution to manage condition data. And here in railway systems, our platform is called Zentrack, and we like to consider this the intelligent ecosystem of railway systems. And we will be deploying Zentrack with HS2 as our monitoring platform to be used in the integrated control centres, to be managed and operated by the flight engineers that Simon described earlier in carrying out their day-to-day activities in maintaining the railway. And perhaps finally, just a few words on what I think are the benefits of this integrated approach. So a former chairman of British Railways, who was chairman way back when I was a kid, a long time ago, but Sir Peter Parker came up with the quotation that railways tend to fall flat on their interfaces. And for me, this really illustrates one of the key benefits of what we're trying to do here with HS2. So as I think most of the audience will be familiar, the turnout system itself forms the interface of a number of different disciplines within a railway. So we have the track system, the turnout system itself, signalling, of course, connected into the point operating equipment, locking and detection. And more recently, either through maintenance or through asset management or through a dedicated digital rail function, or even a combination of all three, would be the asset data acquisition for monitoring. And all of these areas come together in the turnout. And it's not just a technical interface, because of course many of these disciplines traditionally in railway companies are actually separate departments in terms of organization structure and technical competence. So it's a very, very complicated system. And as we know, I think anywhere where there's an interface, there is a risk. So having a single supplier to manage that interface between the systems, we think brings a real benefit. And in many areas, in design, in supply and construction, where, for example, having a single source responsible for the logistics will hopefully mean that we're able to supply all the relevant parts of the turnout system in sequence, planned accordingly to help the construction of the railway, which will take place over the next few years. But then perhaps more importantly, also having a single supplier responsible for the overall system throughout the life cycle of the asset is really the major contributor to achieving the aims that HS2 is trying to achieve, along with many other railways, of a safe, efficient and affordable operation of the railway throughout its life. And critically for turnouts, which typically 65% of the total life cycle cost is actually attributed to the life cycle management rather than the initial supply and construction. So I think real benefits by working together in partnership, by having a single supplier for the overall system, and working in tandem throughout the life of the project will bring real benefits for HS2. So thank you also for listening to me, and I look forward to taking part in the panel afterwards and being challenged with a few questions. Thank you.